If you like these videos, please check out my full course at www.lsat.totaltestprep.net with tons of clearly explained actual LSAT questions written by someone who's mastered test and helped others master it, and an evaluation period where you only pay if you want to continue.
Alright, in this video we're going to cover syllogistic logic, the arguments basics of syllogistic logic. So how does syllogistic logic appear in the argument section? Alright, so first, syllogistic logic appears in certain questions and it has specific aspects to it which need to be recognized. So in what way does syllogistic logic appear in the argument section, and how is it used in the section? Okay, so let's take a look at these statements we've got on the right. We've got all cats are animals, most cats are pets, some cats are black, some cats are not quick, most cats are not fat, no cats are dogs. So those are syllogistic statements, and syllogistic logic is the logic of syllogistic statements. Now, syllogistic statements are related to conditional statements in the sense that, like conditional statements, syllogistic statements will relate two conditions to one another. So you're going to have a relationship between two things. However, syllogistic statements will add specific quantifiers. So all, some are not, most are not, and none. So that's what we see here. We see in all of these statements, we have all of them have use one of those quantifiers: all, most, some, none, no, etc. Syllogistic statements are going to deal with relationships between groups of things. That's why you have those quantifiers. So it's essentially, if you look at the first statement, all cats are animals, you're dealing with a group of cats and a group of animals. And essentially the quantifier, you can think of the quantifier as the nature of the overlap between those groups. So all cats are animals means that all of the elements in the first group are in the second group. Most cats are pets means that a large proportion, or more than 50% of the elements in the first group, in the group of cats, are going to be pets. And the same thing with the rest of them, with some and none. They give you an idea of that overlap or of that relationship between them. Now, looking at it a little bit more technically, so we see that the all and none statements are actually equivalent to regular conditional statements. So we see what I have up here, and I've actually symbolized them. So all cats are animals. You have cat, arrow, animal, and no cats are dogs. Cat, arrow, dog crossed out. I've translated those statements with the syllogistic quantifiers all and no, or all and none, into just standard conditional statements. And you can do that with all and none. And actually, all and none, you can think of just other synonyms for the indicators, for the conditional indicators. So specifically, all A or B says the same thing as if something's in group A, then it is in group B. So all cats are animals is like saying if something's a cat, then it's an animal. So it's not as obvious that you're dealing with the relationships between groups or an overlap between groups when it's expressed as a regular conditional, but it makes sense if you think about it a little bit. If you're saying if it's a cat, then it's an animal, you're implying that there's a group of things out there which are cats, and that a member of that group is also a member of another group. So when you see all, you know that you're dealing. It's as if whatever follows all, rather, it's as if all is if. So all is actually synonymous. We did this. We have this in a one of our conditional reasoning videos. It's all is the same thing as anyone, everyone, each, etc. So when you see all, you can just simply translate that into a regular if then. Now when you see no A or B, that says the same thing as if something's in group A, then it's not in group B. And that's what we have here. No cats or dogs. That's as if you said if something's a cat, then it is not a dog. So you can just kind of think of it mechanically as the no lets you know that whatever is the second group, in this case dogs, you just cross that out. So no cats or dogs, no cats or dogs is a way of, it can be more easily or more straightforwardly expressed as if it's a cat, then it's not a dog. So with no, when you see that no is the quantifier that relates two groups or two elements, what you're dealing with is an if A then not B relationship.